I hope everyone's doing good. I am Mr. Ish. Thank you for joining me for this video. A seemingly easy force question, but it can create a problem for students because there are a lot of little things you have to worry about. What is the question? What force is needed to stop a 100-gram object traveling at 100 miles per hour over 5 seconds? Look what we have over here. The mass is given here 100 grams. We have over here a velocity and it's 100 miles per hour. We have time period over which that stopping occurs is 5 seconds. When you're talking about force, you need to worry about converting this into kilograms. You need to convert this into meters per second. That has to be done, otherwise you will have a mistake. 100 grams will obviously be 0.1 kilograms. But this right here, 100 miles per hour, you have to convert that. You have miles per hour. And you can do a conversion by factor label. It's not hard. You can just do one thing at a time. Each mile is equal to 1.6 kilometers, and that's equal to 1 mile. And then you have 1,000 meters coming from each kilometer. That's what you have. Now look at the hours. You'll have 1 hour giving 60 minutes. You have 1 minute giving 60 seconds. Things will cancel out properly. Mile, mile, hour and hour, kilometer, kilometer, minute, minute. The only thing which will remain will be the meters and the second. That's what you have, and that's what you want. You have 100 times 1.6 times 1,000 divided by 60 times 60, which is a 3,600. What do you get? 44.44 meters, 44.44 meters per second, or you can say 4 over 9. There's a good shortcut here to remember. Each mile per hour is always equal to 4 over 9 meters per second. It's just a good shortcut, which is 0.44 repeating. So 100, you can just do 100 times that 4 divided by 9 and you'll get 44.44 meters per second. This is an excellent shortcut to remember. Each mile per hour is equal to 4 over 9 meters per second. When we're looking at this right here has been converted to 44.44 repeating meters per second. Now we can answer our question. What are our equations? Force is equal to mass times acceleration. Acceleration is equal to change in velocity over change in time. We know our change in time is 5 seconds. We know our change in velocity will be the velocity it's at to 0. Our final velocity will be 0. Our initial velocity was 44.44 because here the object is already moving, so that moving velocity is your initial velocity. The final velocity is when the object stops, 0, divided by change in time, which is 5. What are we getting over here? We can get a good decimal answer. There's nothing wrong with that. We get over here a minus 8.88 repeating meters per second squared because that's acceleration. Force over here is going to be what? Your mass, 0.1 times minus 8.88 repeating meters per second square. We'll get it, and what we'll get is, as our answer, we'll get minus 0.888 in newtons, or what could be another unit? It could be kilograms meters per second square, your mass and your acceleration. Each of these is good. Now the most important part over here, when you're looking at minus 0.888 newtons repeating over here, is needed to stop this object having the characteristics. It's 100 grams traveling at 100 miles per hour and it's stopping over 5 seconds. This minus, what does this minus indicate? The object is moving in this direction. You need an opposing force. Hence, in terms of vectors, the direction of the vectors, it must be minus because it's opposing a moving object. In terms of the directions, they have different vectors. This would be a positive vector, the object, and the force opposing it would be a negative vector because the direction is opposing that object. Force is a vector because it has a magnitude and it has a direction, as you see, a minus, which is your direction, and this part right here is your magnitude. So force over here can be symbolized, and it is a vector. Your answer is this, minus 0.88 repeating newtons or kilograms meter per second square. The little things you have to worry about, always your units, kilograms, meters per second, the conversion has to be done, and always be wary about a negative or a positive sign in terms of what it really means. Thank you. Have a good day.